Section 2 of Integumentary system, this is going to be all about skin color. So skin color is due to a few different things. The first one is presence of pigments. So that's going to be mostly your melanin and your carotene. And then you're going to have dermal circulation, which is a fancy way of saying blood, your blood circulation. The thickness and degree of keratinization of the epidermis. And then ultraviolet radiation can change your skin color, as you see in the summer when you get a sunburn or you eventually get a tan over the summer. But usually, or not usually, you are genetically pre-programmed to be how light or how dark your normal skin color is without any UV radiation, but UV can change the color temporarily. So for pigments, we have melanocytes, which is the type of cell that produces the melanin. Melanin is the pigment that makes your color, your skin, like that brown yellow color. That's the color of the pigment. And the melanocyte is the cell. The melanin gets packaged in these little vesicles called melanosomes. And the melanocyte is located within the stratum basal. So it can be in between basal cells, or it can be just deep to the stratum basal. So kind of like in between the stratum basal and the dermis. And they pretty much stay in that spot. That's where they are. But then the melanin that is produced in those melanocytes, they kind of rise up to the top, kind of like bubbles in a soda, and they bud off into these little vesicles. And so that's how the pigment will continue to rise up into your stratum spinosum. And then for even darker colored skin types, it will also rise up into the stratum granulosum. So it'll go up even further. So lighter skin people, we usually have just have melanin in the stratum basal and the stratum spinosum, and then darker skinned will also be in the stratum granulosum. So if we're looking at a world map, why do people have different colored skin pigment? So the interesting thing about melanin is it kind of acts like a built-in sunscreen. You need a certain amount of vitamin D every day, which you can get from being outside, and vitamin D is synthesized in your cells. It's a hormone. So in order, people that live near the equator usually have more outdoor lives, and they're outdoor more, and they also are more susceptible to get sunburned because they have sunny there pretty much all year long. So their bodies needed to create this adaptability, evolutionary way to keep them protected from the sun's ultraviolet rays, and that became the melanin. So the melanin acts as their built-in sunscreen. So the darker your skin color, the longer you can be outside without having sunscreen on, because it's already built into your skin. It also means that if you have darker skin, you need to be outside longer in order to get your daily dose of ultraviolet rays to produce the vitamin D inside your cells. And then as you go north from the equator and south, these are the representative skin colors, because you are not the most southern regions and the most northern regions. You have less sun on a yearly basis. In the winter, we don't have very many hours of sun. And so you have less melanin because you're not outside as much. And also you need to have a quicker response time to absorbing the ultraviolet rays when you are outside than the people who are around and in the sun all day long. They have much more exposure to the sun, so they can have that vitamin D and be outside longer, and the melanin will protect their skin. But if we live in this region, like where we do here, and then the Netherlands regions are even lighter skinned because they need to absorb that vitamin D. So melanocytes ratio is about 1:4 to 1:20. It changes throughout different body parts. You might notice that palms of hands and soles of feet are not as dark as other parts of your body. And again, everyone has the same number of melanocytes. It's just the amount of melanin that's produced and how far up in the epidermal layers it goes. But we all pretty much have the same number of melanocytes. So here's a picture of your skin cells. So this right here is the stratum basal. This is thin skin. And you can see the brown part. Those are the melanocytes. So they're only in the stratum basal. So this is a cartoon picture of it. So here's the melanocyte right here, and you can see it moves up, and then these are the little melanosomes, or the buds of the pigment that kind of like get pinched off here, and they continue moving up into higher layers of the skin, of the epidermal skin. And then you'll see this like orange yellow stuff. This is the pigment keratin. It's present, a lot of it is present in orange foods like pumpkins and sweet potatoes, things like that. We also do have some of it in our skin. So this giant octopus looking thing is a melanocyte. So keratin, it's the orange yellow pigment. It's in the epidermis, but it's also in your fatty tissue, which is the hypodermis as well. And it's in a variety of orange vegetables. So moving on to the second way your skin gets color. First way is pigmentation. Second way is blood supply. So your blood is red and it provides you with the coloration. So when you blush, your cheeks get pink because more blood is rushing to that area. When you get an injury, it turns red because your body is signaling, hey, we're injured here. We need more blood, because blood brings oxygen, and oxygen helps repair tissue. So it will get red because of the increased blood flow to the area. Hemoglobin is the part that carries the oxygen here in your blood. And so the more oxygen you have, the brighter red blood you're going to have, and the less oxygen, and is a darker red, very dark red. And then if you have kind of a lack of blood, it's going to be blue. It's called cyanosis. You can see it when you have thin skin, like underneath your nails or in your lips when you're really cold outside, because you don't have as much oxygen going there. And so then when your blood vessels dilate or become enlarged, more blood rushes there and it will be more red. Or when they're constricting, then there'll be less blood being able to flow through it, and it will get more white, less red, more white. So here's the blood vessels that are throughout. Here's the hypodermis. It's called the cutaneous plexus. And then we've got these capillaries that provide oxygen and nutrients to the dermis, the pink part, and the epidermis, the purple and the tan part up here. And you'll notice that this very top part here does not have any blood vessels. So if you just cut the very top part of your if you just the top part of your epidermis, it won't actually bleed. You have to cut down into the dermis in order to draw any blood. So we have some skin cancers that can form because of your stratum basal cells and because of your melanocytes. So skin cancers occur due to increased levels of ultraviolet rays over a period of time. The one that's the most common skin cancer is called a basal cell carcinoma. And based on its name, basal, it occurs in the stratum basal in response to ultraviolet. And this one is the most treatable and rarely metastasizes. Metastasize means that it would spread to other parts of your body. That's not good in terms of cancer. You want to keep it located to one region that it starts in so that you can treat it there before it metastasizes or spreads to other areas of your body. The one that can do that is called malignant, meaning that it spreads, melanoma. And so this occurs in your melanocytes, and it can metastasize through the lymphatic system. So go to your lymph nodes, which then transport fluid all over your body. And if it's detected early, the 5-year survival rate is 99%. But if it's not detected until after it's spread, then the 5-year survival drops to 14%. So if someone dies from skin cancer, this is probably the one that they had, malignant melanoma. Although if you don't ever treat the basal cell carcinoma, that can also get dangerous and eventually metastasize as well. So here's a basal cell carcinoma right here. It's raised on the skin. Sometimes it can be flaky or crusty or itchy, and it's something new. It doesn't get dark usually. It just gets maybe pink or a little yellow or white. And so that's a basal cell carcinoma, and that would be something new that you would see on your skin, or you would feel it in your scalp, and like dry skin that never goes away. It could possibly be a basal cell carcinoma. This is much different looking. This is a malignant melanoma. These are the more dangerous ones. You'll notice the It's in the melanocyte, which is creates the melanin, responsible for creating the melanin, so it becomes darker because it's sick. So you also notice the edges, it's not symmetrical, it's different colors. Here's a lighter brown, here's a very darker brown, it's glassy looking. It looks like, it probably started out smaller and it's gotten larger over time, so it's evolved in its nature of becoming, probably started out as a mole, a non-cancerous mole, and then it turned into this. So what you want to watch out for is changes in your moles. Which brings us here. So this is called the ABCDEs of skin cancer. And so these are the things you're going to look for. So these are normal moles that people have on their body, and they're fine. So A is for asymmetry. So if you have something that's normally symmetrical, if it changes to be asymmetrical, that can be a clue or an indicator that it could be cancerous. B is for border. The edges of the border are uneven or crusty or notched or just kind of really uneven here, then that can be an indicator that it's cancerous. C is for color. Healthy moles are uniform in color. It's the same color for the entire mole. And then any changes, multiple colors throughout it, a change in color. Some people have these like red moles on their body. I have a couple of them, and those are fine. That's just an increase of blood vessels that's in your body right there. But they stay red the whole time. But if something turns red or turns a dark brown or turns pink where it was something else, then that is the indicator there. D for diameter, usually they are smaller than a pencil eraser. If one becomes larger than a pencil eraser in diameter, you want to be, calling probably a dermatologist about that as well. And the last one is evolving. If it changes in size, changes in color, it starts to bleed, it gets like just different, it looks different noticeably, then you want to be aware of that as well. And those are the ways that you can check your body for different skin cancers, or to see if you need to go to a doctor to see if it could possibly be a skin cancer. And that's it.